welcome one and all for the webinar on the topic battery storage technologies and its applications. First of all, I would like to thank Skill-Lync for hosting this webinar. Then let's move on. I would like to give a brief overview about today's discussion. First, I'll be discussing about the need of storage technologies and different varieties of battery storage and the key terminologies used in battery storage system. Then we'll move on to our understanding about equivalent circuit-based modeling of battery storage system and the state of the art of various battery storage systems, which are well established in the market today, and various applications based on different tentative parameters that we need to look into before we select any battery will be discussed. Also, we will be discussing about key factors which are affecting lithium-ion battery market, especially with respect to the Indian context, and the global mineral reserves of lithium-ion and battery cell manufacturing unit established across the world. The capacity will be discussed. Moving on to the further discussion, we'll be understanding various advanced battery storage technologies which are still under development, but there is a lot of hope. And we'll be giving a brief overview about the comparison of lithium and sodium ion, especially with respect to the Indian context, and a specific case study where we'll be discussing upon application of a battery storage system for the DC microgrid will be discussed. And also we'll be sharing some thoughts on various application of battery storage system. And finally, we'll be discussing about the career path and job opportunities. Let's try to understand what is storage and why is it needed. I was wondering and searching in Google, Oxford definition says, storage is a means of or action of storing something for future use. It could be of anything, could be your currency, data, or foodstuff. It could be anything, whatever you are in excess now and you would like to store it for the future purpose, that we call it as storage. And of course, it has a lot of relevance for the electrical engineering as well. But before we understand how storage technologies has gained a lot of importance in today's generation, we'll try to understand what is the transformation which is happening at the electrical sector. There are three major changes which is happening. The first one is because of high carbon emission, which is taking place due to the burning of high footprint carbon fuels to meet out the electricity demand. We know thermal power plants, they inject a lot of carbon emissions into the atmosphere. And apart from that, if you look into our locomotive industry, it also contributes a lot for the carbon emission. It is estimated from IEA that for the year 2021 itself, there will be 1.5 billion tons of carbon emission shooted into the atmosphere. That's a very alarming figure. And the second important transformation is the fossil fuels. On the first go, they are highly, carbon. And the other important drawback with this is they are not lasting forever. They will be existing for probably 5 decades, 6 decades. Coal may be existing for a little longer, 10 decades, and afterwards, what will happen to the energy requirement of the whole universe, whole the world? So that is an important concern that electrical engineers really need to cater towards. And apart from that, the growing electricity demand is also an important concern. Across the world, it is estimated for the year 2021 itself, there will be 4.6% growth of electricity demand. So there is a problem with respect to the fossil fuels. It causes greenhouse effect and it is dangerous for our existence itself. And they're depleting. On the other hand, the problem is elevating due to the increase in the electricity demand. So what is the solution for this? The solution would be to look into the renewable energy growth, renewable energy. So renewable energy resources, as we all know, they are available free of cost. As long as world exists, renewable energy do exist. And the renewable energy investment has been considered to be the topmost priority for most of the countries across the world, especially after the Paris Agreement, where most of the countries have pledged for maximum renewable penetration into their existing power system. You can see worldwide there is significant increase in the installation of renewable energy sources, primarily led by wind and solar, because they are abundantly available across the globe. India too is very much interested and on their toes to install or penetrate maximum renewable energy sources into the system. For 2022 itself, there is a goal of 175 gigawatt of renewable energy penetration, which includes 100 gigawatt of PV and 60 gigawatt of wind. But renewable energy sources are not free of cost. They do also come with a lot of challenges. Let's try to understand one by one. The first important challenge with renewable energy sources is they're highly unreliable. We really do not know when wind will be available. We really do not know when there will be cloud over your PV panels. And due to this, there will be a lot of concern with respect to the power extracted out of these renewables. You do not know for the next hour exactly this much amount of power will be available from the renewable energy sources. And because of this, there is a concern with respect to the economic dispatching as well. What is this economic dispatching? We all know that the conventional energy sources are optimized on a 15 minutes basis or a day ahead basis to economically generate power at a lower cost. But with this highly intermittent renewable energy sources getting connected in parallel with the conventional power system, the thermal power plants will really struggle to meet out the expected demand while operating at the economical manner. Also, the power quality concern is very much important because renewable energy sources need to be interfaced with the converters, and converters would inject significant amount of harmonics into the system, and power quality issues need to be addressed. The stability issues. If you can see, the important parameter which really need to be maintained constant throughout the operation of any stable power system is voltage and frequency. We all know this. We cannot allow the system voltage and frequency to fluctuate. It will hamper the smooth operation of the entire power system. But having in place the good amount of or a huge amount of renewable energy sources into the system, because of their intermittency in nature, there will be a lot of variation with respect to the voltage and frequency where they are getting interfaced into the power system. So we need to really concern about the voltage and frequency stability. And what about the grid codes? Some of the grid codes really interested to ensure that the renewable energy sources still getting connected into the system whenever there is a disturbance happening, maybe due to the fault or maybe switching off a huge loads. The renewable energy sources need to be intact with the grid, but the concern with some of the renewable energy sources, such as a doubly-fed induction generator-based wind system, they suffer from poor fault rate through condition. That's altogether a different research area. I'll not dig into it, but that is an important challenge or a research area that one need to really work on it. What about the protection and safety? The renewable energy sources may really disturb the operation of the relays. They may provoke the relays to operate when it is not required, and they may stop the relay to operate when it is really a need of the hour. So the protection is very important concern. And another important concern with respect to this renewable energy penetration is they may cause safety hazard in terms of injecting power when there is a maintenance happening, maybe due to the unintentional lightning type of operation. They may cause life threat to some operator. And government policies need to be worked out to welcome maximum renewable energy sources into the system. These are some of the challenges associated with the renewable energy sources. And how does the storage system would help? Yes, storage can really make a difference. It can help us to absorb the power when there is a huge generation happening with respect to the renewable energy sources. Thereby, we are not wasting the green energy which is available with us and storing it when it is in excess and releasing it when there is a lack of renewable energy sources. The storage really can help us to maintain the voltage and frequency of a system, and the reliability issues can be addressed. So the storage will certainly make a difference. And here I'll be displaying, I've displayed the various types of storage system. The first one is compressed air storage. What we do is we compress the air, And the energy which is stored in this compressed air will be released when there is a requirement at the load side. And the second type is pump storage hydroelectricity, where what we do is we'll generate electricity out of the high head in the hydroelectric power station. And if suppose it is a off-peak hour, what we do is we'll pump back the energy, the water, back to the head using the same electricity which was generated earlier. And we can reuse that water whenever there is a requirement or if there is a peak demand happening. So that's how we can store this hydro energy in terms of increasing its potential. And the third important storage system which is used is flywheel, where we make use of the mass of rotating wheel to generate electricity when there is a requirement. And the fourth important, or this is what we are mainly discussing in this today's topic, the battery storage, which stores energy in the form of chemical form. And the another important technology which has gained a lot of importance in recent days is supercapacitors, which has its significance in terms of cater to the need of high power requirement. It's a high power density device. And the superconducting magnetic energy storage is another important type of storage system, which stores energy in the form of magnetic field and release it whenever it's required. And the hydrogen storage is also gaining a lot of importance, which stores energy in the form of gas and releasing it whenever it is required. And these are different types of storage units, which are primarily used across the world. And let's try to understand the battery storage system, initially with the help of some key terminologies. The first terminology is anode. Anode means it's a negative electrode and it is rich in terms of electrons. It supplies electrons. Cathode, which is capable of absorbing electrons, and it's a positive electrode. Then third terminology is a charge capacity, which is expressed as the quantity of electricity which can be delivered by the cell or the battery. And it is usually expressed in terms of AH or ampere hour. You might have gone to the market and certainly you would have asked for specification of a battery. The typical specification will be expressed, the capacity will be expressed in terms of AH. What it means is how much current this battery can provide and for what duration. A means current, H means hour, ampere hour, how much would be the capacity of a battery in terms of meeting out to the load demand for what duration. That's what is expressed in terms of charge capacity. And cell is a basic fundamental unit of any battery. So this cell is a electrochemical unit that is used to convert chemical energy into electrical energy and electrical energy back into chemical energy. It consists of anode, cathode, and electrolyte. Anode is usually made up of metal, and cathode is usually made up of a metal oxide, and electrolyte could be either made up of a base, acid, or a salt even. For lithium batteries, we are going for salt. For lead acid batteries, we are going for acid. So it depends upon a different kind of application. So battery is nothing but a combination of cells in different manners, whether in series or parallel manner, to achieve the desired capacity. And another important terminology which is widely seen is C rate. C rate is constant charging or discharging rate. And how do we understand this charge rate or C rate of a battery? For example, let's consider 1C. What this 1C means, suppose if we have a battery of 65 ampere hour charge capacity, then if we consider it is to be operating at C rate of 1C, it means it can able to discharge 65 amps of current for 1 hour. Let's try to understand the C rate for 10C. 10C, if the number is increased, 10C means it can able to cater to the requirement of 650 amps of load, 65 into 10, 650 amps of load. If you increase the current, the time would decrease. The more the battery is asked to discharge, the less amount of time it can discharge. That means now it can able to discharge. Earlier it used to be discharged for 60 minutes. Now it can discharge up to 6 minutes only. Let's try to understand in a different way, with another example. C by 10. What is C by 10? Now you're asking battery to discharge current at 6.5 amps constant capacity for, and the discharge time would be 10 hours. I hope this is clarified. So this is very important. And one important thing which also be noted is this may not be an exact linear relationship. A 10C charging or discharging, it may not last up to 6 minutes. The battery can exhaust before 6 minutes itself. It may exhaust its entire charge capacity by 5 or 5.5 minutes. Whereas if you're slowly discharging, maybe at C by 10 rate, it may discharge even more than 10 hours. It could be 10.5 hours or whatever it is. So this is an important C rate because for a particular application, suppose you're considering electric vehicle, you cannot wait at a charging station for 10 hours to go from one place to another place. You really want your battery to get charged as soon as possible. So you need to pick up such kind of battery which can able to charge and discharge at that speed. So that speed of charging and discharge is expressed in terms of its capacity in terms of C rate. So 10C is what I've mentioned here, but practically, lithium batteries is the best which is seen in nowadays market, and it can go up to 2C, or Tesla says they have manufactured up to 4C capacity. So this is what has been seen in the present day market. So the electrolyte, it's a medium by means the charging and discharging take place. So let's try to understand what is energy capacity is. Energy capacity is voltage rating of a battery multiplied by its charge capacity. It is usually expressed in terms of watt hour or kilowatt hour. And another important terminology is state of the charge, or SOC of the battery. It is expressed as percentage of its rated capacity. You might have seen in your mobile phones and all. It says the battery capacity, it shows 50%, 30%. That means it is displaying the SOC of that particular battery at a particular instant. So this is very important parameter. And temperature effect, of course, batteries life really get degrades if you are operating at extreme temperature conditions, either low or high. And what is DOD with this depth of discharge? It is just a complementary of SOC. So suppose a battery SOC is 20%, then the DOD would be expressed in terms of its capacity, which is 80%, 100 minus 20, which is 80%. So let's try to understand what is the need of going for series and parallel combination of cells. Now we have understood what is cell, which is a fundamental unit of any battery. Now let us try to understand the battery in terms of its capacity while we go for series or parallel combination. In series combination, we connect a negative electrode to the positive electrode and we make a series combination. Why do we do that? If we have to increase the voltage capacity of a particular battery, then we go for a series combination. Whereas the charge capacity remains unaltered. Suppose, let us say, a particular cell is rated at 2 volts and 10 ampere hour. If you make a combination of a battery with 3 cells of such identical combination, then the entire battery capacity would be 6 volt and 10 ampere hour itself. Let's try to understand with the help of parallel combination of cells. Suppose if I take the same figure, 2 volt and 10 ampere hour. Now in the parallel combination, the voltage remains same. Just remember your series and parallel electric circuit. Whereas the charge capacity would now increase. Now in this particular example, the total capacity of the battery is 2 volt and 50 ampere hour. If you just take head-by-head comparison, then the entire energy capacity of a battery, whether you go for series or parallel combination, will not be changed. In the series combination, we're increasing the voltage, whereas in the parallel combination, we're increasing the charge capacity, but the energy capacity, which is a combination of voltage and charge capacity, will remain unaltered. Whereas it depends upon the application. Like if you have to go for high voltage rating, then you have to go for series combination. And once you reach that series capacity or the voltage requirement, then you go for parallel combination of cells. So here I have given a brief, I would like to give a brief overview about how a typical battery cell would function. As I already mentioned, a battery consists of negative electrode and a positive electrode. Then it is separated by a separator. This separator would help us to avoid the self-discharge. That means the short circuit between negative electrode and positive electrode is avoided, whereas it is a good conductor for passing through the ions. So what happens during a battery cell operation? Let's take an instance of discharging. During discharging process, the negative electrode, or which we call it as anode during the discharging process, make sure that the chemical potential within this negative electrode would ensure that an electron would be released from the current collector which is attached to this negative electrode. The current collector could be either made up of copper or aluminum. This current collector would release the electron which is coming from the negative electrode and passes it to the positive electrode or cathode via the load. If there is an external circuit, the load would via the means of the load, the electron would be flowing. That means a useful work can be done. This is what we call it as discharging. What happens during the charging process is opposite. During the charging process, the electron would now flow from the positive electrode via the load to the negative electrode. And what is happening at the chemical side? During chemical side, the negative electrode would release a positive ion or cation, which is flowing via the medium of separator to the positive electrode. Electron will be released and a positive ion will be released during discharging from the negative electrode side point of view. And electron will be absorbed and positive ion will be absorbed at the cathode side during the discharge process. It happens in the reverse manner during the charging process.